Hello everyone. I want to talk about electrolytes today in this video. And electrolytes, defined, are substances whose aqueous solution contains ions. So an electrolyte is something that when dissolved in water will conduct an electric current. Okay? So electrolytic solutions contain electrolytes. Gatorade is an example of this. Salt water is an example of this. Sugar water is not an example of this. So that means that even though Gatorade is sweet, like it has sugar in it, it must also have some saltiness in there somehow too, with some dissolved ionic things. Okay, the complete opposite of an electrolyte is something called a non-electrolyte, where the aqueous solutions do not form ions, so they cannot conduct an electric current. Okay, so when we have an electrolyte, we will see a electric current. In non-electrolytes, we do not see an electric current. Okay. And then in class we'll talk about bathing with a plugged-in toaster. Okay, so that's kind of weird. But yes, we will talk about that in a moment here. First, let's talk about strong electrolytes. Strong electrolytes completely ionize. In other words, they completely form ions when dissolved in water. They will form nothing but ions, nothing but ions. So again, as we see this is all you've seen so far. We see how we have sodium chloride, and sodium chloride produces nothing but ions, a cation and an anion in solution. Okay, we could do this again with magnesium bromide. This, you notice that there's a single arrow here. Okay, now that's all you've seen so far, single arrows, but there are double-sided arrows, which means the reaction can reverse itself. So here we have magnesium that forms a 2+ ion, and bromide, which forms a -1 ion. Okay, oh, let's put a plus symbol in there. But of course we need to balance that, so it forms one magnesium cation and two bromide anions. Okay, so that's what are called dissociation equations. Dissociation equations. Okay, where we dissociate. Whenever the word dissociate means to break apart. Okay, so as far as strong acids go, or strong electrolytes, we should talk about strong acids. Okay, and actually before we talk about strong acids, almost all ionic substances are strong electrolytes. Okay, involved with that, we really need to memorize 6 strong acids. Strong acids are strong electrolytes. Okay, you'll notice that there's our list here. It kind of crawled off the board just a little bit, so let me just move this over. There we go. 6 strong acids are, I don't know where that went. Anyway, this is HI. Okay, so we have H2SO4, that's called sulfuric acid. HNO3 is called nitric acid. HClO4 is called perchloric acid. HCl is hydrochloric acid. HBr is hydrobromic acid. And HI, the friendly acid, is also known as hydriodic acid. Okay, so again, make sure you tuck those in your brain. A little word of warning, I'm never going to ask you for these. I'm never going to ask you to produce a list of these things, but it's good to memorize them so you know what strong acids exist, and that means everything else is a weak acid. Everything else besides these 6 is a weak acid. Almost everything else, I should say. There are 1 or 2 ones that other teachers include, but these 6 are good for me. Now, all strong acids should be written as aqueous. Okay, HNO3AQ, HClO4AQ, HClAQ. What this means is the AQ means it's aqueous. It means it's something that's dissolved in water. Okay, and remember, these completely dissociate. They completely break apart in water. All right, they become nothing but ions. And just to note, you'll notice that these strong acids all start with H. So that means with this commonality of having this H+ ion, what makes up an acid? It's the H+ ion. Okay, so you can't have an acid, at least a strong acid, without that H+ ion. Okay, strong bases are the opposite here. The opposite of acids, or at least we can think of it that way. So strong bases, the ones that I want you to know are the group 1 metal hydroxides. In other words, lithium hydroxide, potassium, let's go sodium hydroxide, and potassium hydroxide. Those are good. And there are other ones too, but these are the ones that I want you to know as far as the strong bases go. Now notice the commonality here, the hydroxide ion. So when these strong bases, these strong electrolytes dissolve in water, you will get the Li. Let me show it to you. You will get the Li for example. Okay, nothing but ions dissolving in water. So these are strong electrolytes. Okay, strong electrolytes are basically just about any. Well, again, we have to define what are soluble and insoluble, and then we have strong acids and strong bases. Okay, now you'll notice that when we dissolve strong electrolytes, based off of our discussion, or at least the video on making solutions, you'll notice that all of the water molecules are orientated. The positive side of the polar water molecule is all orientated to the negative anion here. Same situation here, same situation here. However, when you look at the sodium ion, this is positive. So now all the negative sides of the water molecules face it. Okay, so this is something that strong electrolytes do. Okay, they completely dissociate, completely form ions in solution. Okay, moving on. Some special points about strong electrolytes. Going further, sulfuric acid is special. It has 2 H pluses to lose, but only the first one is lost easily. The second one doesn't want to be lost so easily. So I've depicted this by, notice this first equation here. This first equation has a single arrow pointing to the right saying this happens. This is a good thing. This is a very powerful, a very thorough thing. H2SO4 becoming H plus and the HSO4 minus. This is something that works. This is something that is pretty prevalent. Now, this is the same thing as this, but notice it goes this way, and then some of it comes back this way. So yeah, some of it becomes these things over here, and then these things come back and combine again to produce this. Okay? So this is, again, sulfuric acid's a little bit strange as far as that goes, but we do consider it a strong electrolyte. Now let's move on to weak electrolytes, and this whole double-sided arrow thing moving back and forth. Weak electrolytes only produce a few ions when dissolved. So there are some ions and then some molecules. So we need to say that ions are electrically conductive, whereas molecules lack they lack this electrical conductivity, so they're not electrically conductive. Okay? So if I can produce nothing but ions in my strong electrolytic category, then I have a very strong conductor. If I produce some ions in some molecules, now I'm going to have something that's somewhere in the middle. So yeah, it conducts electricity, but not so well. Okay, it's got some conduction in there from the ions, but it's also got some insulation from the molecules. So I want you to know 3 weak electrolytes, and this is the first one. HF is the first one. Okay, this is hydrofluoric acid, and hydrofluoric acid, not only does it become H plus and F minus, but then these two combine together, they actually bump into one another and produce HF again. This is your zapping. This is the electrical conductivity. This is the non-electrical conductivity. That's supposed to be a lightning bolt, guys. I know it's a terrible lightning bolt, but you get the idea. So electrical conductivity from this, electrical insulation from this. So we have something that isn't quite as powerful or conducts like strong electrolytes, and something that isn't that is a non-conductor. So again, somewhere in the middle. Okay. So the second one I want you to know is acetic acid. Okay, this is acetic acid. Now, acetic acid can come in 2 forms. This is basically the inorganic version, or you could have this one, and it's the same stuff. It's just a different way to write it. The H plus, that's dissociable, is here, the source of the acid, but it's also the same one there. Just depends on how you want to write that. Okay, you will see it both ways. Notice ions conduct, and the molecule coming back is insulative. And those are 2 weak acids, and here's a weak base. This is ammonia, and ammonia, when dissolved in water, produces hydroxide, and we end up with something that is a weak base, because you notice it goes forward and also goes backwards. Okay, so we have the ions over here. The ions, of course, are electrically conductive. That's my lightning bolt. And then we have the molecules over here, which is not electrically conductive. Okay, that's, of course, a lightning bolt that's being crossed out. Okay. Now, check this out. Here's vinegar. Here's acetic acid. Acetic acid is vinegar. Notice, here's the molecule. There's no charges here. There's no zaps. There's no charges. There's no pluses and minuses. But here, look at, there's the positive. or there's negative, there's a positive. So over here, we have our lightning bolt. This conducts electricity, and here's one that does not conduct electricity. So again, it goes forward and backwards. Okay? And finally, non-electrolytes. Non-electrolytes do not ionize at all when in water. And actually, water is a non-electrolyte. You cannot get zapped if you take a bath with a toaster, a plugged-in toaster. I know it's bizarre, but just go with it. In pure water. Now, don't try this at home because it's really, really, really hard to get pure water. Okay. So another example, though, is if I take sugar as a solid sugar cubes and dissolve it in water. So that's aqueous. It's been dissolved in water. This will not conduct electric current at all. You cannot get zapped from having a bath of sugar water. Okay. Sugar is highly soluble. It really, really dissolves, but it just doesn't form ions, so it can't conduct electric current. It's very insulative. Okay. So you notice here, this is the sugar cube right here. Okay. Notice these are all water molecules here. They're bumping into it. As they bump into it, they carry the whole sugar molecule away. Okay. The whole molecule gets removed. Not a portion of the molecule, but the whole molecule. Okay. This is what's called an electrolytic tester. And you'll notice that when I have something that is a high, strong electrolyte, such as KCl, it produces a bright light bulb. And I'll try to show you this in class. When I have something that is like sugar, or this is another one, ethanol, it produces no light on the light bulb. It's non-conductive, nothing but molecules here. Okay. Notice there's a bunch of charges here. And when we get to a weak electrolyte, the bulb is dim. It lights up, but it's not as bright because I have some conduction and some insulation. Okay. So that's electrolytes. Let me know if you guys have any questions, but we'll get into this in class.